I'm Omar Nofel. I'm a postdoc at Colorado State University. And today I'm going to present our work on the Lumberton test bed, including buildings and infrastructure flood damage analysis. And the work that will be presented in this presentation is done by here at CSU and also along with work from Nathaniel Rosenheim from Texas A&M University. So the current state of the Lumberton Jupyter Notebook include three major analyses. First is the building damage analysis, and the second is the housing unit allocation, and then the third one is using the building damage analysis and housing unit allocation to predict the population dislocation. So this is how the notebook start in the in-core manual, and this is the main elements within each model. So first, Lumberton is a small city within Robeson County, which is southeast North Carolina. It has like more than 20,000 buildings. Was almost like 20,000. Actually, it's less than 20,000 building. It's a 21,000 in population. And this is the geographical location for each building within Lumberton, color-coded based on their occupancy. So most of the green buildings are different types of residential buildings. The red and yellow and orange are commercial and retail and industrial buildings. So for this study, we used the flood hazard event after Hurricane Matthew in 2016. So Hurricane Matthew started as a Category 1 storm in the Caribbean and ended up with and intensified to Category 5 storm, but it ended up with Category 1 storm on October 8th on the east coast of North Carolina. So then we developed the flood hazard map related with the flood hazard map for Lumberton, North Carolina, based on the hydrologic and hydrodynamic analysis. So for the hydrologic analysis, we were able to capture the flow in the ungauged streams within Lumberton and validate this hydrographs with some of the measured hydrographs. So this shows how the hydrodynamic analysis look like corresponding to the water flow. So this is the second video here is one from Florence, which almost similar to what happened in Matthew, but it was less intense. So this is for the flood hazard modeling. The next is for the community modeling. We developed a portfolio of 15 building archetype. So let's go back. Yeah. So we developed a portfolio of 15 building archetypes that includes 4 residential building, another 4 commercial buildings, including gas station, strip mall, and super shopping centers. Also some social institutions, including 2 schools, 1 hospital, industrial building, community center, and also office and warehouse. Next is that we use the available data about the buildings within the community, including the number of stories, foundation type, roof shape, construction materials, all of these information to map these archetype to real communities. And we did this mapping for multiple communities. And here's it shows some videos that shows some, this is not Lumberton, but it's the same thing with the real community and the mapped community with buildings color-coded based on their archetypes. Then we overlay the hazard map with the community model to identify the exposed buildings and the hazard intensity at each one of these exposed buildings. So this allows us to use our fragilities to by using the flood depths at each building and calculate the exceedance probability of each damage states based on the measured flood depths at each one of the exposed buildings. And the fourth thing is the vulnerability modeling. So for each one of the developed 15 building archetypes, we developed a component-based fragility function that uses components damage to account for the total building damage in terms of the exceedance probability of 4 damage states. So we started by, I think, 5 damage states, and then we reduced them to 4. So here's in this is the old one, which shows 5 regions with 4 curves. But right now, what's in Encore right now is 4 regions with 3 curves. And then we fitted these fragility using log normal distributions. Then we overlaid the hazard map with the exposure model along with the vulnerability model, and then we developed the Encore algorithms calculate the exceedance probability of each one of these damage states and the probability of being in each damage state. So here's it shows the buildings color coded based on the assigned damage state for each one of these buildings. Then the housing unit allocations, Nathaniel developed, we used actually the population allocation algorithm that Nathaniel developed for other test bed, and also Nathaniel is working on other allocation algorithms, including labor allocation to businesses. So he's almost done with the staff allocation to schools, and he's working on other algorithms. This is the concept of how he, like, for example, he was able to assign households for each building within the community, and also identify if this households associated with the staff related to each school within Lumberton community. And then here's it shows, like, for example, here's one of the neighborhoods within Lumberton, and here's a heat map showing how's the population allocated to each one of these buildings. And also this is shows how the so for the third part of this is the population dislocation analysis. So he uses 4 types of data inventory, including the building group data, loss ratio corresponding to each damage state, and also building damage and housing unit allocation. And then he identifies the dislocated population associated with each primary school zone. So, for example, he has the number of not dislocated population, and the dislocated, so not dislocated and dislocated population, and total population, and the percentage of each population dislocation associated with each school zone. So here's the progress on the Lumberton Jupyter Notebook, which I will show in a few minutes. So what we are done right now, we are done with the modeling the community, including the built environment, including building. We are still working on the infrastructure. Social systems, we are done with the allocation model of the households. Still, Harvest team is working on the economic systems. We are done with the damage analysis to buildings, and we are still working on the infrastructure. Currently, there's a big team is working on the post-hazard functionality to include the interdependencies between buildings and networks, along with social institutions. So this is still under progress, and we are expecting to have some notebooks in the January release. And for this part, as mentioned in the testbed summits last week, Elena is still working on the recovery. She actually almost done with many analyses related to these subtasks. And also the University of Oklahoma team is working on the optimization and the resilience goals and constraints, along with optimal mitigation strategies related to Lumberton, North Carolina. So this is for the presentation. So is there anybody have any question before we go to the notebook? Okay, so here's the notebook if you were able to download it from the GitHub. So here's it start with some background about Lumberton, including location and the race, ethnicity of the people who live there. And yeah, so here's the total number of population is like 20 or 21,000. And here's the racial composition of the people who live in Lumberton. And then here's the main publications related to the damage quantification and all the mitigation analysis. You will find 4 papers from the Colorado State team and another paper from Nathaniel Rosenheim for the household allocation, for just your references if you want to know more information about the models. So first, the Jupyter Notebook start by building damage analysis, which initiated by reading the necessary functions to perform the analyses. And just here, like to identify the Python version and the other versions. And then for the flood hazard models, we were able to include the raster maps for the flood hazard after Hurricane Matthew. So we have it in terms of, so you will find one is the depth, which is the flood depth measured from the ground elevation. And this is the ID of this hazard map. And we have another one, which is related to the water surface elevation, which is the elevation of the water measured from datum. And finally, what we use here is this is the flood hazard. So this is the idea of the flood hazard that we use. And then moving back to the exposure modeling. So we have our 15 building archetype defined within the building inventory of Lumberton. So here, this is the idea of the building inventory. And this is the map with the building. So Lumberton is here in the middle, but we try to include like a circle area around Lumberton. So we can have the building within and around Lumberton that share the city facilities if we are going to do some economic analyses and some infrastructure analysis. Sometimes we need to identify some people that live outside the floodplain but work inside the floodplain. So we try to be conservative to include like some buildings around the Lumberton. And here the next thing is the just like transforming this building inventory to GeoData Frame, so we can read some data like the number of stories and if there is a basement and occupancy and building archetype and all of these information. And then we have our 15 building, the fragility functions related to our 15 building archetypes. So here's the concept that we used based on the components fragility. And then here's the concept for the loss function, which is the failure probability of the component multiplied by the replacement cost of the component. And then we get the mean and standard deviation of the replacement cost. And here's the damage description of each damage state. And here it shows how the fragility look like and the loss curves associated with these fragility. So we have here, this is 4 damage states, but the new version should be using 3 limit states with 4 damage states. And here's it shows the curves that we have for the losses. We use 2 methods. One is based on the fragility and one is based on the component loss analysis, which is the blue and black one. And the red one is the HAZIS stage damage function for this corresponding building. And I think this is archetype 2. So this is for archetype 2, which is a 1-story multifamily residential building on a slab and grade foundation. And then here's the log normal parameters for damage state 1, 2, and 3. So using these log normal parameters, we can draw these fragilities, which give us 3 curves corresponding to each one of these damage states. And then here we then map these 15 fragility functions to each building within Lumberton based on the building archetype. So once this building is identified as a two-story residential building on a cradle space foundation, so it will be archetype 4. If it's a one-story residential building on a slab and grade foundation, so it will be archetype 2. So this is how the mapping process work. And then after the mapping, we use the hazard model along with the fragility model to do the building damage analysis by reading all these information about the hazard, community exposure, and vulnerability in terms of fragility. And then this could then go building by building to calculate the probability of exceeding each damage state here in this piece of code. And finally, we will get the damage state. So here we can see that like as we have like thousands of buildings, but the only exposed buildings are like less than 2,400. So the summary shows that the limit states are 0, which means that this for Zeus buildings that were selected to be shown in this summary doesn't get any damage, but many buildings got flood depths and thereby got damage states, like damage state 0 up to damage state 3. So we have the full data in terms of the damage state for each buildings. This is just a summary. And the next is the housing unit allocation, which uses the function developed by Nathaniel. I'm going to present his work. So here, basically, his model reads the housing unit inventory data and also the address point of the housing units, and also uses the I think the building inventory. So he loads this data like the housing unit address point, and the building's inventory was already have it from previous code. And then he run the allocation analysis, and then here's like some summary of the results. And then he starts to, this piece of code, identify the race and ethnicity of the allocated households. So this is a very long piece of code, and here's the final results are shown like showing that the total households by race, ethnicity, tenure in Robeson County for the entire Robeson County. So here's it shows multiple races: white, black, American Indian, and also if it's owner, renter, and the total number of households. And here, yep, and I think, yeah, he then validated this data with the census data. So if we go to this link, you can identify the race and ethnicity, or the population at the census block level. But what this code is doing is that allocates the households from the census block level to the housing unit level. And here's it shows a heat map with the allocated households. There's a small problem with this maps. Like at this location, it doesn't show, but when it doesn't show that there is an allocated household, but when you zoom in this map, you will find that there's already population allocated at these locations. So, and the next is the population dislocation analysis, which reads the informations included the plot group and the loss ratio corresponding to each damage states, and the other information from the population allocation and the damage analysis. And here, then we run the population dislocation, and then the final table here, this is not the final, this shows just the damage states combined with the building information, including versus the floor elevation, building archetype, along with the other information about the building inventory. And then here is this piece of code explores the population dislocation analysis by schools. Like here, it shows how how the population are dislocated based on the service area of each school. So for this specific school, for this zone, or for the households served by this primary school, there's a 3,190 population is not dislocated, but there's a 91 dislocated. Some others doesn't get any dislocations, but some others got a lot of dislocations, which is this is schools. It has like 2,500 not dislocated but with 641 dislocated population, which is 20.4%. So yeah, so this is the summary of the population dislocations. Other analyses are still under progress related to the infrastructure post-hazard functionality analysis, and also other analyses related to social science, including recovery, and other combination between these models. Right now, we are trying to link the building damage with the infrastructure damage, along with the population dislocation, to account for a comprehensive post-hazard functionality for the households. So that's all. Yeah, and I'm happy to take questions.